So I'm Mark from SpeedCurve, and today there's basically three things that I want to cover. First, we're going to explore some examples of visualizing performance data and what makes them great. Then I'd like to share some techniques and approaches I use when visualizing data and building stories around those visuals. In particular, we'll explore the waterfall chart, how we can manipulate it, maybe make it kind of better, and highlight some of the different aspects of a web page's performance. Overall, what I really wanted to do today was encourage you all to start thinking about the teams around you, the wider organisation you're within, and how you can use visuals to engage those people through telling great data stories about the performance challenges you face. So the graphs that we have at the moment are quite technical. How can we encourage the wider organisation to connect with our performance concerns? So I think this insight from Confucius, interestingly, 500 BC, captures why data visualization is so important. When we're talking about speed, we're often talking about shaving off milliseconds here and there to make a difference, and using all sorts of acronyms and shorthand in our language to communicate different performance strategies. It can be hard to understand what someone is talking about and the scale of a performance issue without that visual representation. And it's only really once we start interacting with the system and manipulating code, and that's when we start to fully understand the impact on performance. We have to see it, and then we have to get involved through manipulating those inputs and seeing the effect on the performance outputs to really understand a great system. Now, Brett Victor takes this idea of involvement to another level, and it's importance in understanding a system, and he applies it to creating some wonderful coding tools. They give the creator an explicit connection between the code and a visualization, allowing them to explore and play with the inputs of the data and really understand it through manipulating it directly. So I've got a short extract here, and let's take a look. It's just a couple minutes, but it's quite insightful. All right.
And the code on the side. And this part draws the sky, this draws the mountains, this draws the tree. And when I make any change to the code, the picture changes the video. So the code and the picture are always in sync. There's no compiling line. I just change things in the code, and I see things change in the picture. And now that we have this immediate connection between the code and the picture, we can start thinking about ways of changing the code of and typing. So for example, this number here is the length of the branches. If I want to control that number, I just point my mouse to it, hold down the control key, and I can dial it up and down. So I can see what it looks like for big branches and small branches, and I can kind of converge on what feels right to me artistically. And this works for anyone with the code. I just point to it, dial it up and down. And some of these numbers here, I know what they do. It's still kind of surprising to see it do it. And other ones are just completely surprising. So down here, I've got this for loop where I'm counting to 16. I'm putting 16 little pink blossoms on every branch. And I can turn that down for less blossom or turn it up for more. But look at what I'm doing here. I'm just kind of moving that number up and down around 20 or so. And it has this really interesting shimmering effect. It kind of looks like the wind is blowing through the tree. And the first time I saw this, I immediately started thinking about how I could use this effect for an animation. How would I ever have discovered that if I had to compile it run between every change? So much of art, so much creation is discovery. And you can't discover anything if you can't see what you're doing.
So I think this is a really great illustration of that point. And in the same way, if you haven't played with it, Steve Souders has created a great tool called Gazillion, where you can go in and experiment with different chunks of script, drop them in a page and see what effect they have on performance. Can you imagine if we had a tool like this that allowed us to directly see how performance was being affected by our code? It could fundamentally change the way that we interact and explore performance. So let's explore a few examples of data visualization and the sorts of stories that we can use them to tell. Often our inputs are just this, logs with metrics and lots of numbers, and it's only when we turn them into a visual representation that we can start to see the patterns. Brendan Gregg has done some wonderful visualization work, and here we see a technique of his called frequency trails that shows the disk I/O plots from 100 servers. In the top half here, you can see cache misses and the delay while the disk spins up, whereas in the bottom half, we see cache hits. And it's a lovely way to see 100 servers and get a quick overview of performance in one single graph and see those patterns. This colony graph shows 300 servers and 3,500 zones in a data center. Now, without any real technical knowledge, just using textures and changes in color, we can start to look through this entire data center and identify issues. And we can see that there is a number of dead servers with these large green rings, which we can quickly focus in on. And they were servers that were running cron scripts that were spawning thousands of processes until they hit their kind of resource limits. And so it's really interesting how information encoded as a texture like this can tell you the story of an entire data center and quickly allow you to identify and monitor patterns of usage. In this diagram, we see the step-by-step thought process of how we might translate data into visuals. Here we're taking disk latency and we're taking the height of these graphs and transforming them into color intensity and how that representation changes over time. So we're taking this sort of data, which it's quite hard to tell what's happening here. There's a bit of a drift in latency and the scale is changing all the time. And we're transforming it into this, which is now a static heat map. And we can see that top line there. We can see what that drift and latency actually is. And so the change in form here helps us capture and make the story visible. Now, here's an example of a number I've struggled with. Now, Pat from Web Page Test has devised a great way to measure the user experience of a page load. It's a great alternative to the internal browser events and keeps the focus on what the user is actually seeing as the page loads. But I have to confess that I didn't really know what this number was. Was it a point in time? What was it actually measuring? It felt very abstract until I saw its visual explanation. So as you know, Web Page Test records video as the page loads, and from this calculates a percentage of how visually complete a page is at any given time. You can then plot that visual completeness over time. And here we see two different page loads. On the left, the page very quickly gets to 90%, whereas on the right-hand side, it's stuck at 20% for quite some time. And as you can see here, speed index is actually the calculation of the area above the curve. It's not a point in time at all, but rather the volume of time the page was visually incomplete. And it's really interesting to see people on the web reference this number and misinterpret it. You still see people talking about a speed index score of 1,000 equaling being visually complete within 1,000 milliseconds. That's an incorrect interpretation of that number. And for me, this is a great example of, the number was basically meaningless without its accompanying visual. And so you need to always have these visuals to help tell that story. Did I get that right, Pat? Good. And then, of course, we have our classic waterfall performance chart, which we're here to try and reimagine and stretch and pull today. It lists our resources. It shows us when they start, when they end, how long they took. Inside the blocks, we've got a whole lot of information encoded as colour. It tells us about our connection states and our content types. The vertical lines tell us about start render, when the browser was first able to draw pixels on screen, how busy the CPU is in our document complete. So what's great about all these visualizations is that they tell a story about a performance issue. And stories are important because they capture and help us understand a sequence of events. They're easy to remember and have themes. They clarify and are simple enough to travel from person to person throughout an organisation. But before we can pull apart a waterfall, we need to think about who this visualisation is for, as it's critical to think about your audience. You want to know who's around that campfire before you tell a really scary story, especially about performance. So there are a number of roles within an organisation that interact with performance data or want to understand performance, but they all have quite different questions. So how much should I spend on performance work? How soon does the site become usable? How does performance change across different screen sizes? Is performance hurting our sales? What's the critical rendering path? You can't answer all these questions with the same visualization or even the same performance number. People have varying ability to interpret numbers based on prior knowledge and experience. Is 6 seconds fast or slow? It probably really depends who you ask inside an organisation. Many of us even talk about milliseconds, but in order to appreciate an individual number and its importance, you need to provide context. So here, we've given our 6 seconds some context and used colour, emotive labels and references to other points in time to give it context, and its meaning and interpretation are now clear. And as we all know, 6 seconds is way too slow. So while the number alone can be tricky to interpret, the one thing we have in our favour is that we're all visual creatures. And when we sit around that campfire, there's a common set of cognitive traits and abilities that we can tap into. Patterns, texture, colour and form are used by artists and designers as a shorthand. Here, Seurat, a famous pointillist, uses just a few brushstrokes to hint at the human form, and yet we see 2 women by a lake. In fact, we're so good at seeing meaning where there can be none that this 1976 image had many believing ancient aliens had built face-shaped pyramids on Mars. But once you got a bit more detail, once you added some altitude data and some perspective, we see that it was simply our desire to draw meaning out of some well-placed shadows. We constantly hunt for recognisable patterns around us and project meaning into them. Our brains are wired to scan for changes in patterns, textures and colours. So what I wanted to do was use this combination of thinking about our different audiences and our visual ability to interpret abstract patterns as a basis for a set of explorations into the waterfall chart and the performance stories that it might reveal. All the visualizations you're going to see today are based on data from web page test. There is a wealth of metrics and data sitting under the hood in web page test, just waiting to be interpreted in different ways. Behind each individual test on web page test, there is a huge JSON file, and it's really easy to get in there and pull data out and start manipulating it. This data is commonly expressed like this in a standard waterfall chart. And so to take you through an example of my thought process, one of the frustrations I have is with a waterfall with a lot of resources. It can be difficult to get an overall picture of what's happening with performance as you have to scroll up and down huge kind of pages to try and comprehend the overall. And when we scale out, the detail can be lost and the chart gets really noisy. So the approach of this project is not focused on the numbers themselves, but more of a design-based methodology. And I wanted to strip back the complexity and focus on using basic shapes and colours to explore patterns and relationships in the data that could help me understand the page's characteristics. I wanted to get a feel for the page rather than necessarily know its explicit numbers. So here's an example of focusing in just on that front edge of resources to get a sense of the overall shape of a waterfall. So it can be more easily clearly perceived and scaled down. Then we can start to play with other things. Now that we've got that simplified edge, what does it look like once we put multiple waterfalls over the top of each other? We start to see where there's commonalities and where individual resources are distributed across time in between different waterfalls. Bringing back in the length or the time of a resource can show us straight away where the weight is in a page load. And this is all done just using simple kind of divs to create a grayscale texture, and it effectively gives us a heat map-like image of where the weight is in a page. So that's an example of sort of the process and the playfulness that I really wanted to bring to this exploration. So play is such an important part of discovering how the world works. I wanted to explore and generate lots of experiments. Some of them might work, some of them clearly haven't worked or don't provide any insight, but it's been a lot of fun. It's an iterative process of going wide and exploring and then making a mess, focusing in and understanding and trying to create some meaning. And what I hope you'll get out of this is that you will go and start playing with this data and these visualizations as well. You shouldn't feel like there's any privilege to being a designer. You should be able to get in and play with these visuals just as much as you play with the data and code. So let me just switch over. So what I've got here is a site, and I'll give you the URL afterwards, where you can go and play with each of these interactive explorations. So the first thing I wanted to do here is take that idea of the front edge and see how it feels when you start to overlap. So here we've kind of highlighted the front edge by giving it a 2-pixel kind of edge, and we've also gotten rid of the list of URLs down the side. And as I experimented more and more with these visualizations, it became clear how defining that list is at the side, and it constrains the height of all our waterfalls. So this is just one waterfall, but when we start to layer it up, it starts to get quite interesting. And here we see green lines showing our start render and how divergent they are in between these 10 waterfalls. These are waterfalls taken a day apart for one page. And you can start to get a little bit of a sense of the characteristic of a page as it moves down from the top right. And in here you start to see clusters of imagery and how diverse they are. So I think this starts to give us a little bit of a picture of a waterfall, but it's more attractive than it is kind of useful. So I then moved on from that exploration and started looking at how we can use just basic shape to represent more information. So what we're doing here is that the height of a block is the size of that resource, the width is the time, and the color is its content type. And by doing this, when we scan around the page, we really quickly start to get a feel for the relationship between the size of an asset and its effect on performance. And we start to see some very different things coming through in the way that our resources behave. And so interestingly, when you look at the CSS file here, it's a large CSS file that took 105 kilobytes, but only 173 seconds to load. So that's great. But then right next to it, we have this tiny skinny resource, which is actually just a beacon that's only 35 bytes. And yet it appears here to be delaying our start render event. And so just by bringing that idea of weight into a waterfall, immediately the contrasts become very visible. And engaging with front-end developers or even kind of management, you can give them simple rules for how you might interpret a waterfall like this. So you can give them a visual metaphor of saying, tall skyscrapers, good. You know, long, slow trains, you know, bad. And using that simple language, you can scan through these waterfalls and get a sense of what's going on. There's something really interesting happening here as well, where we've got a set of images that are actually very small, that are taking a long time to load, versus a very similar set of images here that are actually larger and are faster. And immediately the relationship between size and time makes these changes in the waterfall very apparent. So while it's a very simple manipulation of the waterfall, it actually draws us more quickly into where there might be problem areas. And this actually looks like a bit of a problem with the server at The Guardian, where it's delivering these resources very slowly, and the time to first byte was very slow on these initial kind of requests. And now, once I'd done that weighted kind of model, there's one more here. So this is the TechCrunch kind of homepage. And what you can see here very clearly is that they're doing a whole lot of lazy loading of images. So just being able to get a quick overview of a waterfall and see its kind of patterns through using size, and a massive chunk of CSS up here at the front. And you know, coming from more of a front-end developer direction, and background, you know, one of the ways that I can control performance is through size and the number of assets. So being able to immediately see size in a waterfall kind of really helps draw me in. Now, I was quite interested, once I'd done that weighted model, of what it would feel like to bring that back into our layered waterfall. So here we see like the 10 waterfalls again overlaid over the top of each other with some transparency. And by adding the weight back in, I felt like this actually became a slightly more useful view. And that if you were unfamiliar with the site and you ran 10 waterfalls or 100 waterfalls through here, you would start to get quite a good feel for the construction of that page and how it's performing over time. We can see JavaScript and CSS coming down. We see a bunch of fonts load in here, then we get our start render. The same sorts of information that you get from a traditional waterfall, but very kind of visual. And interestingly, once we scale by weight, you can just see it there, all our very small requests, so all our pixel requests like ad servers and things like that, become very distinct from our large resources. And our gaps where the CPU is busy or where the browser is busy painting become really apparent once you bring the weight into the page. So I thought this was actually a little bit more useful. And you can also find anomalies like this where we've got this huge, nearly 0.5 megabyte image that has appeared in one of these waterfalls. Was that an issue with the content management system and so on loading up massive images? Now, then I kind of moved on and went, a frustration I have is still that scrolling up and down. Like I just want a quick kind of snapshot and an overview of how performance is playing out on a page. So what I've done here is just take all those blocks and I've collapsed them down to the same horizon. And what this does is it gets your entire waterfall, doesn't matter how busy it is, onto one screen. And it gives us a little bit like an overview, a bit of a spark line of just how our page feels. And so we can see our start render and DOM events. We see all our content, and this gives us an idea of how busy the browser pipeline is at different parts in the journey to a fully loaded page. And again, you could create some simple narrative around this by saying, look for canyons. These sorts of canyons are really bad. So this is that Guardian page as well, where we've got this tiny little resource here that seems to be delaying our start render. So by highlighting the weight and the size, we build a different picture. And it also becomes a lot easier to compare pages. So Smashing Magazine just published a great article on a lot of the performance work that they've done in terms of improvements. So here I've got 2 waterfalls, a before and an after. So this is before, where we see everything collapsed onto one page. Probably wondering what that huge green box is at the end there. So that's all their CSS kind of being loaded into the end. And then in the next tab here, we've got exactly the same page a few weeks later once they've done their work to improve start render. And what interests me is that switching between these 2 tabs, you can immediately see what is the work that they've done to improve kind of start render. And you can see here that what they've done is that they've moved some of this ad-related JavaScript and they've forced that into after the start render event. And they've made just the HTML the primary thing that needs to be kind of loaded. And the other thing that you can see very visually here is the work that they've done just to optimize image sizes. So we see all these purple kind of images here, drop quite dramatically in size. And everything kind of moves forward as they shave nearly a second off their start render and on load time. So as a visualization, I found this quite useful as a quick shorthand for comparing different waterfalls and overlaying them. And you can imagine a dashboard, with potentially hundreds of these kind of listed down and quite quickly and easily being able to scan through dozens of waterfalls. The next thing I wanted to explore was the idea of diffing different waterfalls and how they interact with each other. So here we're seeing 10 waterfalls overlaid over the top of each other, and I've collapsed everything to the left and the right. Size is on our left and time is on the right. And so what we see here is that the size of pages is very consistent, so there's no real variation in the size between these 10 waterfalls. But on the right-hand side, we see quite a distribution of time. The initial HTML load is actually very, very consistent. So 9 out of 10 here are all overlaid on top of each other. And what you can now look for is basically how gradiated or blurry the right-hand side of these assets are. And it tells you about the variation across these different waterfalls for each resource. And so I think this could be extended and kind of worked on to be able to diff different waterfalls and see what's happening over time. Now, something else that interests me, and I'm quite often was involved in conversations around, what's our cache kind of state? We're using all sorts of CDNs. What's actually kind of happening once it goes through the entire pipeline? And so it's quite interesting just to build quick visual representations from all our individual resources of what's happening on our page. So here all I've done is gone through each resource and added up its cache state and given it a heat map color. So you can see here for this page that there's a 0.5 megabyte that's cached for a year. And this becomes a really nice quick shorthand and can really highlight the difference in strategies between sites. So this is TechCrunch, and over here we have The Guardian. And so you can see just from these very simple visuals, just the difference in caching strategies that come through on these sites. The Guardian here, there's a series of uncached kind of bytes. Then there's a huge chunk of images basically cached for a day. So that tells me about, what's happening on The Guardian and what their content strategy is. That basically a lot of their images just expire from the cache after a day, which is quite interesting, versus cached for a year. So while this is a very high level shorthand, it made me think about what's happening across a set of templates. And I think this is really interesting when you start to look at a set of waterfalls across a website and go, what can they tell me once I start comparing individual resources across a site? So here we've got 4 different templates on TechCrunch, and I've looked at all the resources across them and grouped them together. So this top group are resources that are used across all templates, and the color is indicating its cached state. Then below that we see what's shared across 3 templates, 2 templates, and then what's unique to that individual template. And obviously the article page here, there's a lot of unique content. There's even a massive 1 megabyte kind of GIF on it that's only cached for 3 months. So I thought this was quite an interesting way to get a sense of what's shared and also what's cached, because as I move across a website, if all the resources that are shared have long cache times, then that's great for performance, right? I don't have to download it again and again. The next step was to take that same visual and go, right, well, rather than sorting it by cache time, let's sort it by the order that it actually rendered on the page. And this can start to highlight sort of other issues with just sort of the way that the order comes in. And it was really interesting to see blocks like this, where we've got a great piece of CSS here that is 220K and it's cached for a year, which is great. But why is that not in the top block? It's unique on the home page, and it's shared across these 2 templates. And then the search page seems to have a different chunk of CSS. And these are all around the same size. So for me, that kind of begs the question of, like, is that an opportunity to make all that CSS the same size, the same unique kind of URL, so it would move up into that top chunk? So it's interesting just using form and color and texture to be able to kind of quickly identify where there might be opportunities across a site as well. And here you can see the Guardian site, and immediately you see that caching strategy come alive, and it's great to see that all their shared resources have long cache times, which is great. And then on the home page you see all those images here that are just cached for a day. Now, I kind of wanted to push this technique and see, when it started to break as well. So here, I would argue that this is starting to not work as a visualization, where we've just encoded too much information. We're grouping all our resources, we're looking at their cache times and colorizing, we're scaling the height by the weight of the object, and now we're scaling the width by time. And I think this is an example of where, when you just try and encode too much meaning in a visualization, like I know what it means, and with a bit of learning, you might be able to interpret it as well, but it's not that kind of readable. And if I'm in an organization and we're talking about the cacheability and the reuse of kind of resources, then having a visual like this and just saying everything should be blue is nice, simple language that anyone can buy into within an organization. Now, there's other things that we can do once we start looking at multiple waterfalls as well. So one of the questions that I quite often have about a responsive site is what's happening with the resources across the different viewports. So here we've got one site, this is the Barack Obama site, and I've actually loaded it 17 different times at different viewport widths, and then looked at the size of all those resources. So what we're seeing here is not the visual breakpoints of a site, but what I like to call the performance breakpoints of a site. And you can quickly see here, just at a scan, right down here at mobile kind of widths, we've got small images. Up here we've got large images, and there's a change in the CSS as well between the different kind of viewports. So again, nice simple representations that actually you can use to tell a story about a responsive site and how well it's working. And then we can also use more visual techniques. So imagine using all that resource timing and bringing it through into the front end. A very, very simple technique, but immediately, for the TechCrunch site here, you start to see the differences in the user experience and the way that things load. So, logo loads almost immediately at the beginning. These images are all inline images because they're important, they're above the fold. Down here you see the lazy loading strategy in place, where these images load kind of after the DOM. And then finally, our good old advertising kicks in pretty much, right at the end of the page load. And so using simple colors, and you could encode more information on top of this, we can bring that user experience and the performance data and collapse it together as well. So hopefully what I've demonstrated here is just some quick and fairly dirty kind of hacks from my perspective. Most of these took about an hour to create. They're just using simple divs with inline forms, about as dirty as you can get from a coding perspective. But I hope what you can see is that it's quite easy to take this data, and with a certain question in mind and a certain audience in mind, you can be constructing your own visualizations. And what I'd really encourage you to do is not wait for people to build products or amazing kind of graphs for you, but actually to start getting in there and playing with that data yourself. So did we come up with a better waterfall chart? I think the point here is that actually it's not about the one perfect chart to rule them all, but it's about how you use a variety of visualizations as visual cues in your performance stories. We all need to be creating those bespoke visualizations that connect with a particular audience and in a particular story about performance that we're trying to highlight in an organization. Using the same common waterfall to try and tell lots of different stories can be difficult and confusing for people as well. You're quite often putting a lot of visual information and numbers in front of people and asking them to ignore it as well. I'm always ignoring, the TCP connect times and all those colors. It's like, well, I don't care. It's quite interesting how much we're asking people to ignore by putting the same waterfall in front of people again and again. As I've said, the data is very easy to kind of work with, and you can all get in there and start immediately. So get in there, kind of play with it, think about who's around your campfire, the sorts of questions they have, and what data stories you can tell them to get involved in your performance projects. Don't just tell them about the performance issues, show them. And if you want them to really understand and own that issue and help you solve it in an organization, build them one of these simple visualizations or a simple tool that they can take a screenshot or interact with it, put it in a PowerPoint and use to get that buy-in in an organization. Let them experience that issue directly themselves. If you want to have a play with any of these visualizations that you've seen today and experience them directly yourself, you can do that at lab.speedcurve.com. Go and have a play. I'd love your feedback about which visualizations you enjoyed the most and which one you thought you get the most kind of value out of them. So send me a tweet, send me an email, or just stop me and have a chat at any time. Thanks.